Hello, good morning, good afternoon, good evening, depending on wherever you're joining us today. My name is Scott Lecker on behalf of the Building Smart USA chapter. I'd like to welcome all of you to the monthly webinar. And today we're going to be discussing openBIM in action for transportation and seeing practical demonstrations. So to provide a little bit of background on the content that'll be presented today, this is focused on various technology solutions, and it's from the perspective of a general contractor. So the folks that are out in the field constructing roads and bridges and similar infrastructure assets. And the use case is specifically to be able to view and search these openBIM models in IFC format with the primary business need that they can quickly find the information that they're looking for so that they can build the bridge correctly and efficiently in accordance with the design intent and all applicable specifications. So that's the short version. The long version is this list of bullet points that you see on the screen. Our presenters have seen these before and are familiar with them, so I won't read through all of them. But again, looking for demonstrations of these solution providers and their tools and the ability to provide these capabilities, again, with a general contractor or a construction contractor as the primary user. The data set that was made available for today's demonstration includes the 3 bridges that are part of pilot projects currently underway here in the United States, specifically 2 of them in Pennsylvania and 1 in the Iowa DOT as well. And the last bit of instruction that we gave our presenters was to try to avoid general marketing content and stick to the script of the specific talking points that we had provided. So with that, I will go ahead and hand off to the first presenter. David Alvarez is with us. He is a senior product engineer in BIM and CAD at Esri. And I will let David take it away.
Sorry, let me share my screen first because ACMC doesn't like it. Screen 2, that's the one. Okay, so now everybody can see my screen.
Yeah,
so
looks good.
Yes. So for today, basically, we're going to focus on openBIM in action. Specifically, how BIM data, when properly located, can fully participate in GIS-driven workflows across the asset lifecycle. So today's agenda, introductions, an overview on IFC, geolocation, demos based on the transportation pool fund data sets, and Brett will cover other kind of demos, construction, operation, and maintenance. So let's start with introduction. So my name is David Alvarez. I'm a product engineer for Esri. I work on the BIM CADS group, and I take care of the IFC and Rabbit read for ArcGIS Pro, and also integration with workflows between BIM and GIS. Brett, you want to introduce yourself?
Yeah, absolutely. Thanks, David. My name is Brett Heist. I am a senior solutions engineer here at Esri supporting the AEC industries. And my role within the organization is really to educate and inspire our AEC customers. And excited to be here with you today. Back to you, David.
Thank you. So for overview, so we see IFC is the bridge. IFC allows BIM data to move across platforms without vendor lock-in. The same IFC model can be consumed by different tools while retaining the structure and the meaning. So let's go a little bit on the nitty-gritty. So how IFC or Rabbit is read in ArcGIS Pro. And I'll go in more detail during the demo, but in general, this is the structure. So if you have an entity, let's say IFC doors, if you read it, when you read an IFC file on ArcGIS Pro, it will become doors, and your pieces or your family or types will become attributes into that feature class. So IFC support in ArcGIS Pro. So those are the different formats that we support right now from IFC. But the key ones that we are most interested is the IFC versions, and especially the IFC 4x3 at 2, because that's the one that the Transportation Pool Fund requires or requests for users to use. One thing that I want to highlight, and IFC from the ArcGIS Pro perspective is a read-only format. So you cannot edit it. You cannot do any changes. If you want to do changes to the data, either you use a different application that allows you to do the editing, or you convert it to a geodatabase where now it's a geodatabase, so ArcGIS Pro can edit it. The only caveat there is immediately you create a geodatabase, there's no synchronization. It's just a timestamp copy of the data. So let's go to the fun part. Location, location, location. Location is the common language between BIM and GIS. It describes what, the what, and the how. BIM describes the what and the how. GIS provides the where and the context. Without a reliable location, integration breaks down. So if your BIM isn't correctly geolocated, it cannot fully participate in the GIS-driven workflows. So let's go a little bit on the nitty-gritty. So from the perspective of the geolocation with ArcGIS Pro, you have three possibilities. Possibility one is just a manual work. The user has to do all the work. Possibility two, the user only has to create a piece of information. And possibility three, which is the ideal, which is the one that the Transportation Pool Fund is encouraging, is where all the information is embedded in the IFC file. So the user doesn't have to do any manual work. Let's go a little bit in detail so people understand. Possibility one, what we're generating is two auxiliary files. And I remember that the IFC is read-only format. So those two auxiliary files are not modifying the IFC file. They're two files that give the IFC the information that Pro needs to be put in the correct location. We split the process. So for possibility one, you do it in two stages. Stage one is where you define your coordinate system. Then you type your address, and ArcGIS Pro will generate the auxiliary files needed, but the model will be placed based on the address. So it's not it's in a correct sort of location, but it's not in the accurate position. So then we have stage two, where the user has to use the georeference tools, which we see here. Those are the georeference tools in ArcGIS Pro. And they can move and rotate the model and place it in the right location. With GIS, you can bring your control points, your survey, your monuments, and then you can snap to those to do an accurate and precise placement of the model. We move to the two, where they use all the information, the X, Y, and Z are embedded in the file. So the user only needs to do a PRG file. Just give them the idea of the file where it's supposed to be, which coordinate system needs to be. But this is the one that we are aiming for. Every deliverable should be on possibility three. So what that looks like, here's kind of an example where you have your IFC file. Here, it doesn't have any information, But thanks to these two entities, the IFC map conversion and the projected CRS, your file can be placed in the correct location. So now it can start participating into kind of a bigger picture. It's not just a model, a digital model. Now it's a digital model with the surrounding information. So in summary, we have possibility one. As I show, it's a lot of work. We want basically possibility three. Possibility three is our end goal. Now, this is going back, and I haven't seen this documentation or this reference that much in the US, but this is coming more from Europe and from Asia, where they're starting to give level georeferencing, and they just give it a 10, 20, 30, 40, and 50. Ideally, possibility three is the georeference level 50, where all the information is present. In summary, the different georeferencing levels, as I said, we're always aiming for the 50 because we have the information projected CRS and the map conversion. So it's accuracy integration with GIS. Okay, so let's go with the demos. So here is our bridge. And let me switch. Okay, and I'm gonna switch because I have to drive in the second monitor. So here's our bridge. I did cheat a little bit and I load the file beforehand. So we have it here. We have our bridge and imagery. So let me show the IFC file. So remember that we have three different possibilities. Possibility one, you have to have two auxiliary files. Possibility two, you have to have one auxiliary file, and possibility three, which is the end goal, you don't have any auxiliary files. So your file already has the embedded coordinate system. So here is our bridge, and you can see there's no auxiliary files. So all the information for the position is embedded in the file. Now we have another file that I'll show later. Here's IFC files, but as you can see, I have to create the two auxiliary files to be able to place it in the right location. So I had to do a manual work. So this is the structure. Go back a little bit. So here is my IFC file, and this is from the Esri perspective. We created kind of these distinct buckets that we call data sets, where we put entities that sort of belong into those buckets. So like, for example, if you have doors or curtain walls and panels, they all go in the architectural, while the structure will have the beams, the reinforced elements, the structural foundation. Okay, so here our file, I just drag and drop it, and it shows in the right location. So let's go a little bit on the side. You can see that our model is positioning correctly. Ideally, right now we're using the Esri terrain, so you can see that it looks kind of weird because we're using an old terrain. It doesn't depict all the construction that happened. If you click on any of the elements, you will get the attributes. As with the GIS, you can create a specific definition queries so you can hide or show different data. Here. You can go underground so we can see all the columns and piles, and I'm not a bridge engineer, so if I use the wrong term, I apologize. So we can click here and we can see all the attributes that were populated from the IFC file. You can see all the detail. You can see the information for the bolts, and you can see it's a bolt, and it was a predefined, and gives all the information that that bolt has. Now, this is native reading, so I can send this to anyone, and they will have to have Pro and view it. But sometimes you want to share the data, but don't allow the other organization to make a copy of it or edit it. So we have what we call, okay, it's loading, SLPK. It's converting the IFC file into an Esri format that was developed for the web, so web applications. So it performs really, really well on the web. It doesn't modify the data. It just kind of a carbon copy of the data. Same behavior. The only difference it performs better on the web. So here's an example. From the ArcGIS perspective, we have some tools that we can use. You can do simulation of floods, but I will not go through that. You can also do simulations of viewshed. Go here. Let's go to viewshed. And I can do the analysis from the viewshed analysis. So go. And so my viewpoint is to, I said, somebody driving a big pickup, so less than 10, and I click on it. Wrong user. I want this one. And then my cursor, when I move it, it will tell me what is visible and what is not. If it's green, it's visible. If it's kind of the pink magenta, it's not visible. So there are some tools that you can use from Pro directly. But let's switch and go back. Same data set. Oh, sorry. Yeah. Where is my website? Okay. So same data set. As you can see, I publish it. Here's my bridge. I'm using the native imagery to give it a little bit more information. I can create filters for the data, but I'll show it in the next demo. I can turn off layers, so you can see here. And I apologize, I'm really bad at navigating. Same, you can view underground. Here, we can do the pipe and electrical, like we filter out really easy what electrical and mechanical and piping elements are in the drawing. Click, we get all the attributes that are tied to the data. But the most important one is, okay, there you go. I can do a slice. And the fun part is the rebar. You can see here I'm slicing and I'm seeing all the rebar that is inside of the beams. And I can click on it and it will give me the information for that specific rebar. So you can see that it's a 0.6 nominal steel area and all that information that is inside the IFC. You also have other tools. I'll show it in a second. Also, here you can see how nice the geolocation matches the LiDAR acquisition. Again, we can click and we got the bolt in it. And then we can do some measurements. So you have, and this is out of the box. So I haven't done any customization on the data. Let me just. Let me go get this one. Let's go here. So I can do my measurements. I can do an area. So I can do, it will snap. Here, snapping. And I can get my measurements of the elements. I can do also, that's for the area. I can do just a measurement in the area and it will give you the information. But also, and this is because we're using the Esri data terrain. It's not going to be very accurate, but I can do a profile. So if I go here, and I go here, now I have between the kind of the high level of the road and the bridge. Oh, I forgot to double click. We can see here in that section a little bit is 118 feet between the top of the deck of the bridge and the bottom of the road. You can make it more realistic where there's no exaggeration, and this is what it looks like. So this is the perfect situation where my file had the correct information for the geolocation, and I just sort of drag and drop it in Pro, or I just publish it directly into ArcGIS Online. So now, based on your organization privileges, you can share with different people, and people can interact with it. Now, this is not a bridge. It's kind of hard to combine getting BIM data for bridges or anything. So here is the file that I show you that is multiple files represented the building, and I had to create a projection file and a WLD3. So I have a complete building, and the way that I created it is I converted the data. I merged all the data from the different IFC files into one single geodatabase, and from there I created my digital model. This is in the Netherlands, so I have my, we can see here, a voxel layer that contains all my soil information, and you can see how deep the files need to go in the soil. So we can click in one of the layers, and it's gonna, okay. If you know a Dutch, that will be, I think it's soil, I forgot which one is. So you have that information. You can also integrate your time acquisitions. So here is my LiDAR data set, but I can create a filter, and the filters you can create as many as you want for my acquisition. So this acquisition was made for May 29. So I can compare my model with my mesh data that shows me the current construction and my point cloud that shows me. So yes, there is a discrepancy on the position. This technically goes here, but that's where that was an issue of the control points were a little bit off. So that this gives you the possibility that you can bring a lot of information to your construction process and link them and showcase the construction process using GIS. I think so. I have my web demo, which I already did. So, Brett, this is yours.
All right, let me share my screen. Just give me confirmation.
Let me just stop sharing.
You can see that. Okay. Are you able to see my screen?
Yes.
Okay. Awesome. Well, thanks, David. And before I jump into the demos, I just wanted to take a moment to zoom out, because I think this slide explains really well why everything David just walked through actually matters at an organizational level. So what you see on the screen right now with this infinity loop, it's really representing two worlds in constant motion. We have the plan, design, build on the right, and the owner, operator, or government entity on the left. Same project, very different data environments, and traditionally very little talking to each other. Um, there's lots of changes that happen through these phases, but one thing that doesn't change is location. The coordinates, the spatial context of an asset are constant from the moment a project is conceived to the day it's delivered or decommissioned. Everything else changes. The schedules slip, teams run over, software gets replaced. Location doesn't. And as we walk through this loop and going through the different phases of planning and permitting, design and engineering, construction, project delivery, and management, documentation and handover to this other side of asset management, monitoring and operations, and revenue generation, every one of these phases generates data. And again, location is what ties it all together and keeps it usable downstream. GIS sits at this intersection between the two. And as you can see from the subtitle on this slide, it's that location and GIS are used as the underlying framework for a shared understanding. And that's describing a real integration problem that this slide solves conceptually, but not without implementing those standards and practices that David has been talking about. Those standards exist precisely to make this loop close cleanly. And the reason David spent so much time on geolocation best practices and the transportation pool fund guidelines is that proper IFC delivery is what makes this right side connect to the left side. So if location is the common thread, what does it actually enable? And that's where it gets interesting. This is a digital twin maturity curve. And I want to be upfront because I'm sure a lot of questions people might have right off the bat are, where do I fall or where do most organizations fall? And most of them are down here at the bottom. And that's not a criticism. I think that's just kind of where we're at in this evolution of this technology. And the point though isn't to leap to autonomous on day one. The point is that where you start determines again how far you can eventually go. So let's just walk through this curve real quick before we hop into some demos. Starting down here at the bottom, reality capture, static virtual models, 2D, 3D representations or visualizations. What David showed, importing IFC, publishing to ArcGIS, that's descriptive. It's the foundation and it delivers real value on its own. When we start weaving in IoT sensors, connected data environments, and creating a more dynamic virtual model, that's when we move into the informative level here. Now your twin is live and it's reflecting real world conditions in real time. Layer in AI, machine learning, forecasting, advanced analytics. Now you're anticipating what's coming, not just seeing what's happening. And then lastly, in these last two levels, scenario modeling, remote inspections, eventually self-learning systems. This is where the industry is heading. But not without, again, the strong foundation. And the demos I'm about to show you sits at the descriptive level with a clear line into the informative and beyond. And that's intentional because, again, just to drive it home, you can't skip the foundation. So if your IFC data isn't properly geolocated, if attributes don't survive the BIM to GIS handover intact, none of these upper levels are going to be reachable. And that's really the entire argument for everything I think David kind of just covered. So let's make this concrete, no pun intended, and look at two real examples. One from active construction and one from a post-construction operation scenario. And while the data isn't necessarily transportation related, the workflows and the value add are. So let's go ahead and dive in. So this first demo that we're looking at is a live construction progress dashboard built directly from a 3D model. No custom development, no specialty extensions. This is just standard ArcGIS Online. And I want to show you what it does, but also walk you through a couple of workflow decisions that aren't obvious and can make a real difference to arrive at this point. So we have the 3D scene as our anchor that has the BIM model published and live in a browser. The structural elements are spatially accurate and color coded by status. We have widgets that are pulling live from the feature data, so attributes, green for completed, yellow for in progress, and red for not started. Anyone on this call can read this, right? Without a GIS background, a construction background, it's not software specific. It's just easy to read, and that's intentional. A PM, an owner, an executive, they can open this URL, understand where the project is in under 30 seconds without scheduling a meeting to get to that answer. One thing worth noting here, if you are looking to replicate this workflow in the future, the data was published as a 3D object scene layer, not a building scene layer. That's the publishing path that keeps the data editable and what makes the live status updates possible. The other thing you'll notice is the attributes you're seeing on these elements, they came directly from the BIM or the IFC. So they survived the workflow intact because the model was stood up correctly from the start. And that's the geolocation and data structure conversation David was just having made visible. So then I can come in here and not only view all those existing attributes, but I can edit and use them to inform the model as it is. So you're not re-entering data here, you're just consuming it. Because we published, again, as that 3D object, that element is editable right there in the browser, and no additional software are really needed. And then those indicators will update. And that's an important point about where we are in this life cycle, that this is during the project. So an example, during construction, active construction, live updates, the team is using the GIS as the operational layer while the work is happening. The next demo flips that. We're going to look at this. We're going to look at what this looks like after the project is done and the asset is handed over. All right, so this is, again, I know this isn't transportation related, but I think the workflow and the outcomes still are. This is the Naperville Swift Water Treatment Plant, a post-construction scenario. The asset is built, and now it needs to be operated, maintained, and managed. No different than a transportation asset, right? And what makes this interesting is that the data model carrying all of that, the geometry, the attributes, the spatial context, all again came directly from IFC, and nobody had to re-enter it. Same workflow, fundamental workflow as that first demo that we saw. It's an IFC processed through Pro, like Dave was showing, published to ArcGIS Online, geo-referenced, and spatially accurate. But this is where the difference is, what happens next. So instead of just having this be a reporting dashboard or a progress dashboard, this model can actually become the foundation for a connected operations environment. So we're able to start connecting these to external business systems, and the model serves as the foundation for that. If you remember back to that loop with the owner operator, if I can go back real quick. Remember this loop on the left for the owner, operator, and government, asset management, monitoring, operations, all that good stuff. This is that loop running. All right. So every asset has attribution associated with it that came from the IFC or the BIM, the class, type, status, location, install date. Again, nobody had to re-enter any of that. It was all carried over. And more importantly, this is where the digital twin maturity curve starts climbing, where we can again connect to external business systems like ArcGIS Indoors, for example. So that same IFC model is also powering indoor navigation and space management. Facility staff can navigate the plant, locate equipment, and understand spatial relationships inside the building. Again, all from the same model. And this can be even something that is used to specifically locate or get directions to an asset within the facility. Again, being based upon that same model, just serving another purpose. And then in this case, directions or indoor navigation. Inspections and work orders can also be a starting point from this foundation. They can be directly tied to the asset layer, like we see here. So crews in the field are working against the same model, creating records, and even closing work orders. You can connect to things like city works and update conditions, with all this flowing back into that same source of truth. So this is what the model becomes the foundation actually means in practice. One well-prepared model, properly geolocated, handed over correctly, and it's powering navigation, maintenance, inspections, and work order management simultaneously. That's the value that David was speaking to in getting the foundation right. So what I hope you take from both of these demos is that the value isn't just in getting the model into GIS, it's what you can do with it once it's there and how long that value lasts. From the first structural element going into the ground to a facility manager pulling up a work order 10 years later, this is the same data model, the same platform doing real work across the entire life cycle. With that, David and I are happy to take your questions and dig in.
Oh,
Unless you had anything else, David.
yeah, let me finish sharing my screen just really quick. So why this didn't, okay. Okay, thank you to Iowa DOT, HDR, and the Transportation Pool Fund for providing one of the models, the bridge. It was good for testing. So at the end, kind of this is the summary. If you plan ahead and get all the kind of ducks in a row, you will be able to do a really nice transition as how we show it with the Iowa DOT model. It had all the position ready and all the attributes. So when it went to the GIS, it just went without a hiccup. Here are some resources. There is some georeferencing, and it goes in all the details, all the very nice learn lessons that you can use for learn how to georeference. Other more advanced where you can use coding to organize your data better, and some technical papers on geolocate, CAD, and BIM files from the start. I think so. That's it.